Hello everyone, welcome to my channel Our World. Today we are going to discuss about the part 2 of Interior of the Earth of class 8 Geography WBPSC syllabus. So at first, let us go through interior layers of the Earth. So there are few layers of the Earth which has different characteristic features and different density as well as thickness. So we'll begin from the first toward the last, from surface towards the center. At surface, there will be the first layer of continental crust and it is known as seal. Then the next one will be Sima, that is oceanic crust. Then there is the layer of mantle. Mantle is further divided into two parts, upper mantle and lower mantle. And these mantles, the upper mantle also has one different layer. That layer is totally made up of magma or viscous materials and it is known as asthenosphere. The upper mantle, also known as Crophecyma, and the lower mantle is known as Nymphocyma. Then the core is further divided into two halves, the outer core and inner core. The outer core, it is actually liquid or semi-liquid in nature, and the inner core is solid in nature. So let us discuss about the discontinuity found in these layers or among these layers. Between Seal and Sima, the Conrad discontinuity found. Between crust between crust and mantle, the Mohorovicic discontinuity is found. Then between Crophecyma and Nymphocyma, the Rapathy discontinuity is found. Further, between upper mantle and outer core, the Gutenberg discontinuity is found. And at last, between the outer core and inner core, the Lehmann discontinuity is found. Now, let us proceed towards the next page. At first, we are going to discuss here about the crust. So crust, it is the uppermost layer of the earth. Some major constituent elements of the crust are oxygen, silicon, aluminium, iron, calcium, sodium, magnesium, potassium, and other substances are also present here. It has two distinctive layers, that is seal and which are separated by Conrad discontinuity named after seismologist Conrad. So seal or continental crust known as seal because it is composed of silica and aluminium. All landform features are part of it. It extended up to 50 to 70 kilometers of depth made up of granitic rocks, and average density of this layer is 2.7 to 3.0 gram per cube. The next layer is Sima or the oceanic crust. It is actually consists of silicate and magnesium. It is heavier than continental crust and it lies underneath continental crust. Average thickness of this layer is 5 km and average density of this layer is about 3.0 to 3.3 gram per cube. It is totally consists of basaltic rocks. Now let us move toward the next portion, that is mantle. So mantle, it lies below Mohorovicic discontinuity, which is also the separation zone between crust and mantle just after crust, extended up to 2900 km depth inside the earth, and the density, it actually varies from 3.3 to 5.7 gram per cube. It consists of dense and rigid rocks behave like elastic solids in this layer. Divided into two parts, upper and lower mantle, and separated by Rapathy discontinuity. The first of all, upper mantle. It is also known as Crophecyma. So here, Crophecyma actually made up of four types of minerals or substances, or we can say elements. These are chromium, ferrum, silicon, and magnesium. And it has extension from 30 km to 650 km. The temperature in this layer varies from 500 degrees centigrade to 900 degrees centigrade at its upper portion. Now next one is the lower mantle. It is also known as Niphesyma, where nickel, ferrum, silicon and magnesium are the main constituents elements. Extension of this layer from 650 to 2900 km. The next one is temperature. The temperature of this layer actually uh, above 4000 degrees centigrade at its boundary. Now next we have also one more topic, that is asthenosphere. So what is asthenosphere? The upper part of upper mantle is known as asthenosphere. So we can see here in the picture, this whole area is asthenosphere. Here the viscous materials are actually floating or moving here and there with the help of thermal convection current. So let us discuss about this layer. It is known as low velocity zone because it consists of molten rocks materials which behave like elastic solid or plastic solids, for which reason the velocity of seismic waves decreases in this layer. So while the P wave or S wave travel through this layer, their speed or velocity generally decreases due to the presence of viscous materials or molten materials. Now next is, it lies at the depth of 20 to 80 km. The material are molten due to excessive pressure and heat of overlying rocks. Convection current is created in this layer. So here the convection cell or convection current is created. Now at last, our last topic is the core. The core, it lies at the center of the earth, just below Wishart-Gutenberg discontinuity which separates core and mantle. The Earth's core has a radius of about 3470 km, which is little more than Earth's radius. It mainly consists of heavy metals like iron and nickel. Average density in this layer differs from 9.1 to 13.1 gram per cm cube. The temperature in this layer generally remain between 5000 to 6000, sometimes it may extend upward. Now next is, it has two distinctive layers, outer core and inner core, which are separated by Lehman discontinuity. So both the cores, outer core and inner core, they are actually separated by Lehman discontinuity. The outer core is liquid in nature and the inner core is solid in nature. So let us study about the outer core and inner core. First of all, outer core, located beneath mantle, consists of liquid iron and nickel. Extension is about 2900 to 5100 km depth, and density of this layer depends between 9.9 to 12.2 gram per cm cube. Now next is the viscous iron in this layer creating electromagnetic field. S wave can't pass through this layer due to its liquid nature. So the S wave can only pass up to further passage of S wave is restricted here. They generally deflect or reflect from this particular layer. Now next one is inner core. So inner core, it is located after outer core and consists of solid nickel and iron. Extension is about 5100 to 6370 km of depth. Then density of this layer varies from 12.6 to 13.0 gram per cm cube. And at last, the temperature of this particular layer, it is the highest possible temperature found. The temperature at this particular layer is about 5000 to 6000 degrees centigrade, and it sometime may rise up. So thank you all of you for watching my video, and I hope you are enjoying these videos. You can stay tuned for more in the future update. So bye all of you.